You're listening to a podcast from 702 and Cape Talk.
702 and Cape Talk.
The Naked Scientist.
Right now, we are crossing over to the Naked Scientist. Hi, how are you, Chris?
Oh, I'm fine, thank you, Labu. How are you?
I'm fine, thank you. It's lovely talking to you. You are going to be telling us about the 2016 Nobel Prizes for Science that were handed out this week.
Yep, I thought this would be worth mentioning, given these are the premier accolade in science.
Absolutely.
Now, the week began with the announcement of the medical prize, which was given for the process called autophagy. And that's a Greek word, and it means eating yourself. Now, we're not talking about turning people into sort of self-inflicted cannibals. What we are talking about is a process by which our cells, and there is something like 50 to 100 trillion cells in the human body, those cells make a lot of rubbish. They make a lot of stuff that they eventually need to chuck away. And if they don't get rid of it, then the cells can be compromised. And this process of autophagy, which was discovered by a Japanese scientist, his name was Yoshinori Ohsumi, what he found is the recycling system that enables cells to degrade, break down, and then scavenge back, reuse the nutrients from the things that they were going to throw away. So our cells have been in this recycling game for a very long time. It's really important, this. It's not just important to health. It's important because many diseases like cancer, many diseases like diabetes, and other diseases like Parkinson's probably have origins or associations or links to this process and this process going wrong. So understanding how it works is fundamental to a lot of different diseases and solving those diseases, which is why I think he's been recognised.
What an interesting topic.
Sorry.
Yeah. So let me just invite our listeners to join us. If you would like to ask anything to the Naked Scientist, you can call us on 011 883 0702 or 021 446 0567. But go ahead, Chris. Tell us more.
Yes, I was going to say the next one that then emerged was physics. And this one was slightly less easy to explain. It's the topic of topology. And if you don't know what topology is, it's really best described by it's a branch of science in which things don't change in a smooth way, they change in a stepwise fashion. And the person who was on the panel announcing the prize actually got up with a bunch of food items in his hand to try to make this a bit simpler. And he held up a bagel, he held up a cinnamon bun, and he held up a pretzel and said, these foodstuffs, they all taste different, but in fact, to a topologist, the only thing that matters is that they have different numbers of holes in them. Obviously, the pretzel had 2, the bagel had 1, and the cinnamon bun had none.
Okay.
Why does this matter? Well, the point he's making is that you can't have half a hole. So you either have a hole or no hole, or you have 2 holes. And so, therefore, holes change in a stepwise fashion. And to a topologist, a teacup and a saucer are effectively the same if the saucer's got a hole in it. And so the point is that these 3 scientists, and they're David Thowlis, who's from Cambridge, also Duncan Haldane, another Cambridge physicist, and Michael Kosterlitz, another Cambridge physicist. None of them ended up with their career in the UK. They all went to America, but they pioneered this field of topology, which and did some very interesting work which gives us new insights into exciting materials, things like topological insulators, these bizarre materials where they'll conduct electricity around the surface but not through the interior of the material. It is very important because it helps us to understand how things like superconductivity work, and when we shrink things down to just 1 atom thick like a layer of graphene, we begin to understand how these materials at the extreme will behave. And so it underpins the future, but it's very hard to get your head around.
Wow, sounds very fascinating. Anything else?
Well, then the last one to be announced, which was, I think it was Wednesday morning, was the Chemistry Prize. And this has actually gone to 3 chemists. Fraser Stoddart is one of them. The other one is Jean-Pierre Sauvage, Frenchman, and Bernard Feringa, who's a Dutchman. Fraser Stoddart, originally from Scotland, now working in the US. And this was given for micro machines and manufacturing or engineering atoms, so moving things around at the atomic scale. The initial breakthrough by Jean-Pierre Sauvage was to interlink two rings of molecules. So you make a ring, a bit like if you were to put your thumb and your index finger together and make a ring with your right hand. If you then took your left hand and made a ring by joining your thumb and index finger together of your left hand, but you did it with your fingers through the first ring, you'd make a linked pair of rings. It doesn't sound particularly complex, given jewellers do this to make nice necklaces all the time, but in fact, at the level of a molecule, it's incredibly hard to do, and it was a new way of joining matter together, because we'd been comfortable with the idea of chemical bonds linking atoms together, but the whole idea of linking molecules with a mechanical force like that was groundbreaking. Then along comes Fraser Stoddart. He made a molecule which was a bit like a dumbbell shape, but it had a ring around the dumbbell, and by providing heat, he could actually make the ring slide backwards and forwards along the dumbbell, and he used it to make a molecular abacus, which is quite fun. And then Bernard Feringa really has gone the whole hog and managed to make rotors that spin when you shine light on them. And these are just bunches of atoms, right? This is incredible. And his rotor spins at 12 million times a second. But he then went a step further and they announced a car, a four-wheel drive molecular car. So it's basically a series of molecules that form the chassis, and then there are four molecular motors where the wheels would be, and you give that a burst of ultraviolet light and it will drive along.
Wow, that sounds very fascinating. It's 15 minutes after 10. And when we come back, we will be talking to Dr. Andy. You are listening to The Naked Scientist, who is telling us about all the 2016 Nobel Prizes for Science that were handed out this week.
702 and Cape Talk.
The Naked Scientist.
If you have just joined us, you are listening to the Redi Tlhabi Show on 702 and Cape Talk. My name is Lebora Mafoko and I am the Friday stand-in. And right now we are talking to the Naked Scientist, and we've got a question from Dr. Andy. Hi, Dr. Andy from Johannesburg.
Hi, can you hear me?
Yes, very well. Ask your question to Dr. Chris.
Thank you. I was wondering if the concept of autophagia is a similar concept to autoimmune disease. Would that be the root of autoimmune, or how do they fit together?
Okay, Dr. Chris?
Well, they're similar in name, but really that's where the two diverge, because autoimmunity, auto means self and immunity means immune response. And autoimmune diseases are very severe and very common in some cases. They can underpin things like rheumatoid arthritis, they can underpin things like lupus, SLE as it's also known. They can also cause things like thyroid problems, and diabetes. And it's where the immune system, for reasons we don't understand, turns its attention on your own tissues. Normally we're defended from this happening because there is very strong recognition of what we refer to as self. Your cells are decorated with various molecules and markers which your immune system is educated to ignore. And it, on the other hand, is also educated to ignore things that are not regarded as nasty. This is called tolerance. For some reason, and we don't know why, in some people, but there are certainly genetic reasons why this can happen in some people, and it may be because an infection triggers it off in the first place, the immune response turns itself against certain markers on some of our cells in some of our tissues. And because you're making those cells with those markers all the time, you have this chronic immune response, which ultimately leads to damage to that part of the body. Now, autophagy is eating yourself, and it's a process that goes on inside cells. Our cells are metabolic machines. They're turning over all kinds of structures and things all the time. And in the same way that you have a dustbin outside your house and you dump your rubbish in there and you put your recycling in one bin and you put the stuff that's going in landfill in another. And the idea is that with the recycling, then someone can take that away and turn it back into something useful. Well, when your cells go into a stress response and they begin to starve, if they don't have access to enough materials to recycle, to make new things for themselves, then the function of the cell would be compromised. So autophagy is one way in which rubbish is disposed of, things that are broken and clapped out get broken down, but importantly, the useful materials are recycled within the cell and redeployed. And that process is much more fundamental because it actually keeps cells healthy in the first place rather than just affecting whether or not the immune system's interested in them. I'm not sure that there's a direct link between autophagy and autoimmunity, but I might be wrong because this is an emerging field, and at the moment we're just beginning to scratch the surface of it.
Thanks a lot for that. Next on the line is Thomas from Diepsloot. Hi, Thomas.
Yeah, good day. Thank you for your great show. I want to ask the scientist. I had a spinal operation, a lumbar, at Netcare N17. When they stitched back my spine, the left side is working, the right side is punctured. I want to know, can they fix the side that is not functioning to can function the same as the left side? I did write a letter to the CEO, or 3 of the CEOs. I've had no reply from them.
Okay.
Can you just explain for me a little bit more about what you mean by the right side isn't working?
What happens is that all the function of my back, like my movement, bending down, turning left, turning right, walking, all of that is carried by the left side. So I walk like 50 meters, and my muscle the left side muscle on the spine will like lock, because it's carrying the load of the right-hand side. And
are you saying that you've got weakness? Is the right-hand side less strong? Do you have any numbness or tingling, or do you have pain on the right-hand side?
It's just like there. It's not functioning as the left side is functioning as a unit that it's supposed to be.
Yes, I think I gather what you're saying, and you have my sympathy. I'm very sorry to hear that. And the problem is that spines are complicated things, and they're very hard to put right. Your backbone has to bend several hundred million times during your lifetime, so it's an incredibly well-evolved piece of machinery. But when it goes wrong, it's a very big problem to try to fix. And roughly about a third of spinal surgeries do things which make people better. About a third of people who have spinal surgeries tend to stay about the same, and unfortunately up to 1/3 of people may get worse through having some surgery. Often when people try to fix things in the spine, you're going for the best function that you can, and sometimes you end up with a compromise between range of movement and function and relief from things like pain or the risk of an unstable spine impinging on, that means pressing on and harming nerves. It may be that in your case they've had to make some compromises. It may also be that it does need further investigation to make sure that the function's as good as it can be and that there isn't more problem there that needs to be resolved. But to be honest, it's very difficult for me to offer you any more than just generic advice, because A, it's not safe, B, I can't see you, and C, I'm not your doctor. So you'd need to go and talk to someone who is your signed up physician and get them to make sure you've been properly examined and that they're not missing something.
Thanks a lot, Dr. Chris. It is 10:23 and our next caller is Sonette. Hi, Sonette from Newlands.
Hi there.
Hi.
My question is to do with a condition called adrenal fatigue. I do understand about, in layman's terms, if possible, I'd like to get a clearer picture. I do understand it's the adrenal gland, and that has to do with adrenaline and I think the fight and flight and cortisol. I'm not sure what adrenal fatigue actually, what's happening when you have that condition.
Hello. Well, I haven't come across the word adrenal fatigue. It doesn't mean it doesn't exist. It means it's just something that I haven't actually come across. But your adrenal glands sit on top of your kidneys. That's why they're called adrenal, because of the Latin. They sit just above the kidney on each side. And there are two parts to the adrenal gland, and they're about thumb size. They're about the size of the end of the joint of your thumb, your adrenal glands. And the outer coating, the cortex of the adrenal gland, makes one group of chemicals and signals, and this includes cortisol, which is the chemical you mentioned, and this is one of your stress hormones. Cortisol is released in response to a signal from your brain, and it visits every cell in the body, and it has an important role in setting the body clock in all of the cells in your body, but it also triggers the way in which your cells respond to stress. And people who are chronically stressed and depressed tend to have very high levels of cortisol. It can put up your blood pressure. It can make it less easy for you to control blood sugar if you have too high levels of cortisol. On the inside of the adrenal gland is what's called the adrenal medulla, and it is bright yellow because it's full of cells called chromaffin cells, and those cells have the metabolic machinery in them to make adrenaline and noradrenaline, its chemical relative. And those two chemicals are squirted out into the bloodstream in response to signals also from the nervous system when we have an anticipated stressful event coming, we're excited about something, or sometimes because the cells become autonomous and they start squirting out the adrenaline when they shouldn't. In both cases, the adrenaline and noradrenaline go into the bloodstream and they then visit all of the cells in your body, which increases the metabolic rate of those cells, including in the heart. And in the heart, it makes the heart beat faster, it goes to your lungs, makes you breathe faster, it goes to your eyes and makes your pupils open up. So lots of effects systemically around the body. I'd need to find out whether or not there is a medical phenomenon called adrenal fatigue. There are certainly reasons why the adrenal gland stops working, and if people have an adrenal gland that doesn't work properly, especially the outer part, the cortex, they can get a condition which is called Addison's disease. That's one example of an autoimmune disease. And in that case, they become deficient in cortisol, and if you don't have enough cortisol, you can die. So it's an important condition to diagnose.
Yes, and perhaps adrenal fatigue has the opposite, where you're getting too much of it.
Well, certainly there are reasons why in some people they make too many of the chemicals that come out of the adrenal, but I haven't heard it dubbed adrenal fatigue, so I don't want to speculate as to what the term means because I haven't heard it and I might be making it up. So I'd like to check I've got that fact right.
Thank you. That makes a bit of sense.
Thanks a lot, Sonette. Next on line is John from Randburg. Hi, John.
Hi there. Hello. Thanks very much for taking the call. I just wanted to find out, Chris, is it possible that we can actually see a star, albeit a new star or an old star, that is more than 200,000 light years away? I watched the program recently and it just seems unrealistic that we can actually physically see these things. And how do we measure it? I'll listen on the radio if you don't mind.
Hi, John. The answer is 200,000 is that's just up the road in space terms. In cosmological terms, scientists are now seeing back billions of light years. I think the limit is currently back to more than 12 billion light years. And so scientists are now beginning to see some of the first stars that shone in the universe, and that they are so far away that the light has only now begun to reach us, or the vestiges of that light as it's spread out across space. You certainly can see it when you are looking up into the night sky and you're seeing stars which are chiefly stars in our galaxy, our Milky Way galaxy. The size of the Milky Way galaxy it's about 100,000 light years across the Milky Way, and there's a couple of 100 billion stars in it. But some of those smudges on the sky aren't the Milky Way, they are other galaxies. The Andromeda is our next nearest cosmological neighbour, and that also has billions of stars in it. With decent telescopes like the Hubble Space Telescope, which doesn't have to worry about the atmosphere, it can see these stars, and we can detect how far away they are, and we can detect what direction they're moving in by looking at the light colour. Because as space expands, because the universe is getting bigger, this means that the space between us and a distant star in another galaxy, for example, that galaxy is moving away from us, which means that as the light comes to us from that galaxy, it stretches out a bit in the same way that a police car going down the road driving away from you, the sound of the siren changes and drops in pitch. Light coming to us from a distant object that's moving away also stretches out and it becomes more red in colour. And because we know what the colour of the light coming to us from it should be, because all elements have their own unique wavelengths or colours of light, and we can see how far offset the light is, the degree of offset is proportional to how far away, in other words, how fast that object is moving away. And you can use this as a yardstick to effectively estimate how far away and how long ago that object emitted that light, and therefore how long it's been travelling to get to us.
Thank you so much, Dr. Chris. It's been so educational. Thank you for everything that you have shared, and to all the callers.